Here we go, page 11 in your review packet. Which plane must be perpendicular to? Let me highlight the plane they give me. A, E, F, G. A, E, yep, it's this top one right here. All right. Which plane must be perpendicular to A, E, F, G? All right, what's the best way to describe this right now? Okay, any line that is perpendicular to that plane. Okay, any line that's perpendicular to that plane. So if we take line AB right now, okay, line AB is perpendicular to that plane. Agreed? Okay. Since AB is perpendicular to the plane, any plane containing AB is also perpendicular to the plane. I should have gave you a right angle there. All right, you got me on that one. I should have put a right angle in for that one. Okay, or told you the line was perpendicular. Okay, so again, let's say FD was perpendicular to the plane. That means any plane containing FD would also be perpendicular. Okay, so for this one, any plane containing AB, which would have been AB, CE, would be perpendicular to it. Okay. Yeah, that definitely should be in there. That is perpendicular. Oh, I did put it in there, didn't I? I just cut it off there. It says AB is perpendicular to, so I did put it in there. See at the top of the page, 10? Oh, did you ask for 11?
No, 10.
Okay, yep. Do you see at the top of the page, it says in the diagram below, AB perpendicular? Okay, so we're good to go. Ella, page 10, number 8. Okay, we've got a little midpoint where I'm given the midpoint and an endpoint, and I have to find the other. Okay, coordinates of the midpoint. So midpoint right in the middle, F5, 6. The coordinates of A are 1, -6. What must have been the coordinates of B? Now let's remember, midpoint, this is directly in the middle of these two. Meaning, as I go on the x-axis from 1 to 5, how many units am I traveling? 4 units to the right. Everyone agree? I'm traveling 4 units in the positive direction. And I am right in the middle. So if I want to get to the end, I got to go another 4 units to the right. So I was at 5. When I go 4 units to the right, where do I end up? At 9. And here we go. Now you're on the y-axis from -6 all the way up to 6. So I'm at -6. I travel all the way up to 6. How many units did I travel? 12 in the positive direction. And again, I'm right in the middle. So if I want to get to the end, I got to go another 12 units in the positive direction. Where do you end up at? 18. The alternative way, if you don't want to do this, what we called the skip method when I reviewed this with you, is actually use the midpoint formula. X1 plus X2 divided by 2. Y1 plus Y2 divided by 2. What's the X coordinate of the midpoint? X coordinate of the midpoint in this problem? 5. So you could say 5 equals, what's the X coordinate of point A? 1 plus the other X coordinate divided by 2. And then what was the Y coordinate on my midpoint? 6. So you could say 6 equals, what was the Y coordinate for A? -6 plus Y divided by 2. You could also solve it that way. All right, using the formula. Keep reviewing. Is this formula going to be given to you? No, not given to you. All right, yes.
On page 9, number 3.
Okay, I think you guys are worrying a little bit too much maybe about unit 1.
So, yeah, but my problem was...
Which problem are we looking at?
Number 3.
Yep.
The C part?
Yep, 4 non-coplanar points. You could have 3 that are coplanar, but if that 4th one's not on the plane, all 4 are not coplanar.
Okay.
Like if I go B, A, H, they're all coplanar, but then I'll throw G in there. So those 4 together do not form a plane.
So basically this has to me 4 points that do not form a plane
Correct.
together.
Just because 3 of them do or 2 of them do, it's all 4 together.
Okay.
Okay? Good. Stacy. Okay, we got a proof going on. Good, good. All right, let's dive into this proof. Stacy, one more time, where did this page come from again? Page? Okay. All right, here we go. Proving Rn parallel to SP. Here's my question to Stacy and everybody else. Do you see a special type of angles up there that are formed by Rn and SP? You could give me a lot. I know you could give me alternate, like you could probably say these two right here. But do I really want to deal with those two? No, I don't know anything about them. Everyone say I have 1 and 2 and 3 and 4. If you combine those, what did we call those type of angles? Here's my transversal. They're on opposite sides. Alternate exterior. If you remember the theorem, if 2 lines are parallel, what do I know about alternate exterior angles? They should be congruent. So let's work backwards. If you can prove to me SWL and RTQ are congruent, you'll have a pair of congruent alternate exterior, which would make the lines parallel. All right. How do I make them congruent? Add them up. Yep. So I would have, don't want the highlighter. Try that again. I would want angle 1 plus angle 2 equal to angle 3 plus angle 4 by addition. And now, how am I going to get SWL and NTM? What am I going to do here? I'm just going to substitute in. Angle 1 plus angle 2 is just another name for angle MTN. Congruent to the other angles, what? SWL by substitution. And now, okay, they're congruent. Now I know my lines are parallel. RN parallel to SP. What type of angles were they? Alternate. Alternate exterior angles. Congruent implies I have parallel lines. Okay. Definitely know all the types of angles formed by parallel lines. We got corresponding alternate interior, same side interior, and make sure you know the theorem that goes along with each. Any topics? More questions here? Frank, let's roll, bud. Where I use HL. Sure, I don't know if I put any in there, but. Okay, I know I put one. If you guys don't mind copying one down. I don't know if anybody, I don't know that packet as well as I should. I know I put one on my enriched, on the AB one though, so. Anybody find, if you find an HL, assignment midterm materials. Again, this isn't in your packet. This was in my Geometry AB Kids packet because I know this ends up being. If you just want to focus in and why HL, that's fine. Here's the bottom line. Ready? I wanted to show what reason these two triangles are congruent. First off, can we narrow this down to 3 reasons before I go nuts? Which one can I definitely eliminate? I don't even care what it says above. Yeah, side angles. Even though I know some of you want it to be away, it's never going to be away. Okay, so we can eliminate that right off the bat. All right, let me show you what was given. RSW is isosceles. Vertex angle W. I should have been more specific. But this is the vertex angle, meaning, where are my congruent sides then? RW and WS, right? Because the vertex angle, remember, is the non-congruent angle. The other two, remember what we called those? Base angles are the congruent ones, which means the sides across need to be congruent. So I have RW and SW. I also have W as the midpoint of UT. W, midpoint of UT. What other 2 segments are congruent? Definition of a midpoint. RU perpendicular to UW, ST perpendicular to WT. Perpendicular lines form right angles. Good so far. All right. So why is this HL? Well, is this angle in the middle of those 2 sides? Is this angle in between those 2 sides? No. So that's why it's not side angle side. It's got to be in between the 2 sides. Now, if you remember, what's the side called across from the right angle? Hypotenuse, and the other 2 sides are called the leg. So this is why this would be HL. If I asked you to do it in a proof on Monday, you have to remember, tell me their right angles, and you have to tell me what about the triangles if you want to use HL. They're right triangles. So somewhere down in your proof, I would say triangle RWU and triangle SWT are right triangles. What would be my reason there? Right triangles have right angles. And then you could say by HL. So if you end up using HL in a proof, please make sure they're telling me they're right triangles. Okay? Joanna, whoo! If you think this is intense, wait till we get ready for the regions. Which one? This beast? All right. Another proof. What page again, Joanna, for those watching at home? 27. And somehow I got to get D to E. Okay, D to E. A lot of you would say, oh, D is congruent to E because they're alternate interior. I'm done. No, okay, I agree that they're alternate interior, but what's the only way they're congruent if I have what type of lines? Parallel. And is DC parallel to EF? No. So this is not a 2-stepper right now. It is not a 2-step proof. Can you get me any angles congruent by AB being parallel to DC? If these 2 lines are parallel, what 2 angles up here are congruent? B and C, because they're alternate interior. So I can say angle B congruent to angle C. Parallel lines imply alternate interior angles congruent. And we're trying to get D and E now. We're trying to get to D and E. All right, is there anything you guys can do here? I'm glad you asked this, Joanna, because I think some kids are just going to try to, it's one substitution, I'm done, but I need a little more than that. Take two at a time. Maya, go ahead. Which one? Okay, here, ready? Take a look. She took that given right there along with what we just wrote about the alternate interior. C congruent to E. B is also congruent to C. So Maya, one more time, you know which two angles again? B is congruent to E. That's one substitution that was just applied. What's the other given we haven't touched yet? Remember, use all the givens. Which one haven't we touched yet? B congruent to D, and you already just found out that B and E are congruent, so conclusion? If B and D are equal, B and E are equal, E and D are equal by a second substitution. Not one, a second one. Good question. Rose. You say page 55? Okay. I'm ready. Which one? A. Little partitions, everybody. I can almost guarantee that one's going to be on there. Partitions. Okay, break it up into a ratio of 1 to 1. So how many congruent parts am I going to break it up into? Okay. Real quick, just a little visual of what we're about to do. We're trying to find the point that breaks it up into two congruent parts. What's another name for that point am I asking for? That's the midpoint, right? So I can do it. Do you want me to do it? Do you want me to do it, or do you want me to go through the whole partition? Yep. Okay. No problem. Here we go. So the first thing I'm going to do and this would go for any ratio right now, just not 1 to 1, any ratio. So x coordinates, I start at -3 and I go to 7 on the x-axis. How many units? Anybody? How many units am I traveling? 10. And you want to divide that 10 up into two equal parts, right? So I take the 10 divided by 2, and that tells me every time I go 5 units, I'm breaking it up. Well, how many times do I need to go 5 units? Well, not twice. I'll be all the way over here. I only want to go once, right? 5 units once. Everyone, yes? 5 units once. It all depends. And again, it all depends on if that's a 3, I'm going to multiply that by 3. If that's a 10, I'm going to multiply that by 10. So 5 times 1, yep, 5. Where do we start on the x-axis? -3. And you're traveling 5 units to the right. Where am I going to end up? At 2. And let's do the same thing for the y's. Where'd you start on the y-axis? 4, and you go to 6. How many units total did you travel? 2. Again, cut it up into 2 equal parts. 2 divided by 2, 1 unit. And I'm only going to go once, so 1 times that 1. Where do we start on the y-axis again? At 4. Add that 1. I'm at 5. 2, 5. Ethan in the back. It all depends. Ready? I'm multiplying by 2. Well, it's got to. Well, let me say this. If you go from the first coordinate to the second one, yeah. But if you decide to change things up because you're feeling a little saucy next Monday, and you wanted to go from 7 to -3, then I would multiply by 3. It all depends on what direction you're going towards. Okay. Most people do go left to right, so that's why they multiply by the first number. But if you're feeling saucy, I don't know if I would on Monday or risk of that one, and you want to go backwards, you multiply by the second number. Nathan? Sure. So you want to do a little part B, 2 to 3 here? All right, here we go, Nate. -9 to 1. That's a total of 10 units. Right? How many parts are you dividing up into? 5. So I'm going to take that 10 units and divide it up into 5 equal parts. So that tells me every time I go 2 units, I'm going to divide it up. But I need the point that's 2 to 3, though. So I can't just go 2 units and be done. That'd be 1 to 4. All right. Instead, and this is what Ethan was just asking, here you go, 2 times 2, which tells me 4 total units from what starting point? -9, going in the positive direction. So I'm going to end up at -5 on the x-axis. Okay. And you guys will be, if I do ask a partition question, you will be provided with a graph, or there will be scrap graph paper provided. What I would just do for a check, graph both your points, graph the partition point, make sure it's on there. Okay, because if you graph it, say it looks like this, and all of a sudden your point's here, it's pretty good you got it wrong. All right, make sure it lands somewhere on your line. All right, you're going to be there for 2 hours, so make good use of it. Let's keep this train going here to the bell. Let's keep it going. No other topics, or you guys know what? 3. Just go back to the setup of it. Take your time on part 1 and 2, because it's no partial credit and it's a 6 out of 10, 60 out of 100 points. All right, that's a lot. 3/5 of the test is part 1 and 2. And did I go over yesterday that when it says 4 questions, 1 question, that may also contain a construction? Did I go over that yesterday? I'll tell you that. Okay. When it says question, that question could be a construction. Do this. Nate? I'm not telling you that. Sorry. Have we done coordinate proofs? Okay, you answered your question. There's 3 proofs. I think we've gone through like a chunk of proofs that you could say possibly could be on here. What's a huge proof topic we've gone over? Congruent triangles. What's another one? I don't know if I'd call that huge to be part 4 or 5, but you could use parallel lines in a proof, absolutely. But I don't think that would be the end result. Quadrilateral, indirect, coordinate. All right, we just listed off 4 of them right there. 4 big chunks of proofs that we've gone over this year. All right, and there's 3 on there. So be prepared. Okay. Anything else you want me to review? Keep it coming with the questions here, guys. This is going to be your time here. I know we were a little short on time today, but yes, Joanna. Page 11, number 11. If plane A is parallel to plane B, intersects the plane A and line M, and intersects plane B and line M. Okay, here we go. I need you to hold that, Frank. Thank you. Sorry. Two parallel planes. They don't touch, right? And then I have a plane C that's going to slice them in half, or not in half, but just go through them, intersect them. Okay, so here's 2 parallel planes. Here's line M on here where it intersects. Here's line N down here where it intersects this plane. What can you tell me about those lines as well? They have to be parallel. The best type, like if I do ask this, it'll be 1 multiple choice, is to try to draw a diagram, visualize it with your test, just like we did there, right? Because it's a lot easier to see that those lines are parallel. All right. Anything else here? All right, guys, keep coming strong every day here. I'll be after school today. You guys know when my review sessions are. Don't take it lightly. Don't take it lightly. Make sure, start getting your supplies together now. Make sure you got everything all set.